Okay, so question number 5, part A, using graphical method, solve each of the following pair of simultaneous equation. And the simultaneous two equations are given. Y is equals to 3 minus 5x, and the other equation is 5x plus y minus 1 is equals to 0. Very simple. All we have to do, I have told you, step number 1, first we have to change these given equations into a regular form. Second, we will have to find out the coordinate. If there is no coefficient attached with y-axis, then simple, you will put 3 numbers and get the value of x. And if there is a coordinate attached with the y-axis, all you have to do is you have to see if the constant is divisible by the coefficient attached with the y variable. So let's see. First we have got this equation 1 and equation 2. I'm going to change these equation into a regular form now. So y plus 5x is equals to 3. Okay, simple. Now 5x plus y is equals to 1. Fine. Call this equation A and equation B. That no coefficient is attached with the variable y. So all I'm going to do is I'm going to put 3 numbers 1, 2, 0, 1, 2. Okay, and we will get the value. So if x is equals to 0, x is equals to 1, x is equals to 2. So I have already explained these steps, that's why I've done it quickly. So we have got the value y is equals to 3, y is equals to minus 2, and y is equals to 7. I'm going to put this in a table. So this is the table for equation A. Solve question number, equation B and get the table. So in equation B, we can see that y variable has no coefficient. I'm directly solving it quickly. So the value of y is 1, y, and another value is minus 4, and the third value is minus 9. I'm going to make another table for equation B. Okay, now these are the 3 points for equation B. So now we have all 3 points. We can plot a graph and we will find out the intersecting points between our straight lines A and B. Question number 5A for the graph. First of all, let's talk about the scale. No particular scale was mentioned in the question, so I have made a scale that should be visible, more visible and easy to plot the 3 points that we have calculated. So I have taken on x-axis 10 small square is equals to 1 unit, and on y-axis 5 small square is equals to 1 unit. And I have seen the maximum number on each axis. So on y-axis the maximum number was 2, and on x-axis the maximum number was 2, and on y-axis the maximum number was minus 9. So I have divided my x-axis, I have set the range of x-axis from minus 3 to plus 3. We can set it to minus 2 and plus 2. It's okay, but it was actually, there was a space, so I have further divide the x-axis into 3. But you can set the range from 2 to minus 2. Okay. Secondly, on y-axis, I have divided the y-axis into segments, 9 segments. See, and 1. And we can see that 1 unit makes 5 small square makes 1 unit. So this was it. See, now you can clearly see that when I plotted these 3 points that we calculated in the previous part of this question, see the 3 points on equation A and for equation B. To get the point of intersection between the 2 points, you can clearly see that these 2 points do not intersect at any point. They are parallel to each other. So it's quite visible, and we can conclude that the equation A and equation B, do not intercept each other. So there is no point of intersection between them, and therefore we cannot find any solution through the graphical method. Okay, so question number 5B, advanced level, using a graphical method, solving each of the following pair of simultaneous equation. And these 2 equations are given. The method will again be same as I have explained earlier. Now first step towards the solution will be change these given equation into regular form that I have explained earlier. Regular form means variable on one side of the is equals to and constant on the other side of the is equals to. So this equation, the equation number 1, is already in regular form. Now only we have to change the second equation, that is 15y is equals to 35 minus 5x. So I will keep 15y on one side and minus 5x will come on the other side of this equals to and will become plus 5x, and 35 will remain there. Now this is our equation A. Step I've told you, we will see if y variable has a coefficient or not. If y variable does not have the coefficient, then it's very easy. You have to put 3 simple values for variable x and get the value of variable y. But here in this question, we can see in equation 1 that it has a variable that coefficient is attached with variable y. So if we will, let me copy the equation first, then if we will put the value x is equals to 0, what will happen? If we will put the value of x is equals to 0, then this x will become 0, and only thing left on the other side of is equal to is 7, which is not divisible by our coefficient. So we will have to suppose a value that would go to the other side of the is equals to and become completely divisible by the coefficient attached with our y variable. So x is equals to 0 is no, we cannot put x is equals to 0. What about x is equals to 1? Let's see. If I am going to put x is equals to 1, then this 1 will go on the other side of the is equals to, and 7 minus and will become minus 1, and 7 minus 1 we know is 6, and 6 is completely divisible by our coefficient, that is 3. So I'm going to put x is equals to 1. So we have got our first point now. Alright, 3y 6 and y is equals to 6 divided by 3 will be 2. So the first value of x comma y is, so the first point on this line is 1 comma 2. Now let's see what other points we can choose. Now if I will put x is equals to 2, so what will happen to our equation? If I'm going to put x is equals to 2, then this 2 will go to the other side and become minus 2, and 7 minus 2 we know is 5, and 5 is not divisible by 3, so we cannot choose this one as well. Now what else we can do? If we will put x is equals to 3, what will happen? Okay, now this 3, if we will put x is equals to 3, then this 3 will go on the other side. 7 minus 3 will be 4, and 4 is not divisible by coefficient 3, so we cannot put x is equals to 3. Let's see, x is equals to 4, so maybe 7 minus, okay, so 7 minus 4 will be 3, and 3 is completely divisible by our coefficient 3. So if x is equals to 3, then equation 1 will be 4 plus 3 y is equals to 7. This 4 will go on the other side, will become minus 4, 3y is equals to 7 minus 4, and 3y is equals to 3, and 3 and 3, that means y is equals to 1. So the other point we have got is x comma y is equals to 3 comma 1. So this is the second point on this equation. Now let's find out the third point. Alright, so if I'm going to put x is equals to 5, let's do it directly and quickly. Now we have got the idea how we can find out the point. That would be completely divisible by 3. X is equals to 5, then 7 minus 5 would be 2, and 2 is not completely divisible by 3, so we cannot put this. Now if x is equals to 6, now 7 minus 6 is 1, and 1 is not divisible by 3, so this cannot be done. Now again x is equals to 7, so yes, 7 minus 7 is 0, and y will become 0. So okay, let's put if x is equals to 7, then our equation 1 will be 7 plus 3y. Okay, 7 minus 7 is 0, then 3y is equals to 0. Do you understand this? 7 minus 7 is 0, so I'm directly doing it over here. 3y, okay, sorry, y is equal to, then y equals to 0, and x comma y is equals to 7 comma 1. So I'm going to make the table out of all these working. Sorry, this is 4. And I'm sorry, in a hurry I've written it wrong here. I've got 3 points. We can plot graph on a graph paper, but before that I am going to complete this equation, the working of this second equation, and once we will get all 3 points of the other equation, then I'm going to put all these points and plot a graph. So let's see, equation A. For equation A, similarly, as I have told you before, that a coefficient is attached with y variable. See which number I can put, so that the final constant, the final value will be completely divisible by 15. So let's see, if I'm going to put x is equals to 0 in equation A, then this whole equation 5x will become 0, and 35 divided, we will have to divide 35 by 15, and we know that 35 is not completely divisible by 15, so 0 is not a good option. Again, if I am going to put x is equals to 1, what will happen? See, if I am going to put 1, then 5 multiplied by 1 is 5x. 5x will go on the other side and will become 30, and 30 we know is completely divisible by 15, so x is equals to 1 is a good option. I am going to put x is equals to 1. If x is equals to 1, then our equation A is 15y plus 5 comma 1 is equals to 35, and 15y plus 5 is equals to 35. Now 15y is equals to, okay, so 15 to 30. So the value of y is 2. Now x comma y is equals to 1 comma 2. So this is one point that we have got. Now let's suppose the other 2 points. If I will put 2, x is equals to 2, what will happen? 5 multiplied by 2, 5 multiplied by 2 will become 10, and 35 minus 10 will be 25, which is not divisible by 15. So this option is wrong. Again, x is equals to 3. Let's see, 5 multiplied by 3 will be 5 multiplied by 3 will be 15. 35 minus 15, which is not divisible by 15. So this option is also wrong. We cannot use this option. Okay, let's see if we can put x is equals to 4. So 5 multiplied by 4 is 20, and 35, this 20 will go on the other side. 35 minus 20 is, yes, it's, let's see if I can put x is equals to 4, then our equation A will be 15y plus 5 multiplied by 4 is equals to 35, and 15 minus 20 is 15. 15 cancel, y is equals to 1, applies that, and x comma y is equals to 4 comma 1. Got the second point on our graph. Let's go to the third point, and the third point I'm directly doing it. You can see if x is equals to 10, right? Now 15y plus 5 into 10 is equals to 35. 15y is equals to 35 minus 50, which is minus 15. Now the value of y is minus 1. Now I am going to make another table of all these 3 points, and we will plot a graph, sorry. Okay, so I have plotted, I have calculated or written all the 3 points on the table, but we can see one thing very clearly from this table is that for equation 1, out of these 3 coordinates, we can see this coordinate 1 comma 2, 4 comma 2, and for equation A, whose coordinates we have just calculated, it also has 2 common coordinates. See, 1 comma 2, 4 comma 1. Alright, now that we have got 2 tables, one for equation 1 and the second table was for equation A, we can compare these 2 tables, and we can see very clearly that out of these 3 coordinates, 2 are common. Yes, see, 1 comma 2, 1 comma 2, 4 comma 1, and 4 comma 1. So if we are going to plot these points on our graph, that we are going to do, but I'm telling you roughly that if we are going to plot the graph, maybe this could be only emerge out as only one line. That means 2 lines may overlap each other, or they have infinite numbers of solution. So in the graph of question 5b, we can see that all the 6 points overlap each other, hence only one line is formed.
Thank you for watching. Subscribe for more updates.